Hello, my name is Jason Seitz. I'm an applications engineer in the Precision Systems product group. Today I'd like to give you a demonstration on setting up the LMP91050 evaluation kit. Let's begin by navigating to the LMP91050 SensorAFE Evaluation Board Software website. Web address is ti.com/SensorAFE. From this page, if you scroll down, follow the Design Resources Hardware and Software Development System link. Locate the LMP91050 folder, and under the Software heading, click the SensorAFE Software Download link. For simplicity, let's save to the desktop. Download will take approximately 1 minute. Let's locate the zip file and unzip it. For simplicity, I will also unzip to the desktop. Next, let's install the LMP91050 SensorAFE software. Double-click the installation executable and follow the instructions on the wizard. Accept the default directory and create a desktop icon. And begin installation. Installation has finished. And you can see it has created an icon. At this point, you could choose to run the SensorAFE software without the board as a standalone evaluation tool. However, since we have the evaluation boards, let's plug them together and see how they work. We're now ready to assemble the LMP91050 evaluation kit. First, open the LMP91050 evaluation board box. Now let's open the SPIO4 data capture box. Inside, you'll have the SPIO4 board and the USB cable. First, connect the 9150 evaluation board to the SPIO4 board, like this. Next, connect the USB cable between the SPIO4 board and your laptop, like this. For our test purposes, we will also be shorting jumper J2, which will short input to common mode out of the LMP91050. If you're installing the SPIO4 data capture board to your PC for the first time, the Found New Hardware wizard will pop up. It'll ask, what do you want the wizard to do? You want to install from a list or a specific location, and click Next. Now you want to search for the best driver, and you want to point to the folder where the driver is located. It will be located on your desktop in the NSC USB v1080 folder. Press OK and click Next. Click Next again. And the wizard will install the software. If a Files Needed pop-up box appears, point the browser to your desktop and locate the USB folder. And click OK. You're now finished with the Found New Hardware wizard. Now navigate to the SensorAFE Software, the LMP91050 icon. Double-click to run the software. Now, this is the LMP91050 SensorAFE software. Let's navigate to the help bar and do a step-by-step instructions on how to use the SensorAFE software. You start by selecting a sensor, clicking the thermopile type, and you now will see the options for thermopile sensors. Let's go with the Hyman HMS J21 sensor. Now, by default, the LMP9150 has PGA1 disabled and PGA2 disabled. So go to step 2 and enable PGA1 by clicking on the PGA1 box and turning PGA1 on. Step 3, turning PGA2 on by clicking on the PGA2 box and turning on PGA2. Step 4, external filter. We'll keep that direct PGA1 to PGA2. In other words, not utilizing the external filter. Click OK. Common mode. Going to the common mode box, we have a selection between 1.1 and 2.5 volts. Let's keep it at 1.1 volts. Gain, again going to the PGA1 box, we'll keep the default at gain of the stage 1 at 250. Step 7, PGA2, keep that also default at gain 2 of 4. So that's a complete signal path chain gain of 250 times 4, or 1000. Step 8 is to set the offset DAC. By default, it's 128, which means that there will be 0 millivolt offset on the output. Let's keep that okay. Another way of changing the output offset is by going to the user inputs, which can be found on the upper left corner, and going specifically in and adjusting the offset voltage to, let's say, 50 millivolts, and clicking enter. You will see the DAC now has updated from 128 to 126. Now we're ready to measure the performance. On the left, in the middle, is the estimated performance based on your inputs: supply current, what the common mode voltage will be, what the gain will be, phase delay, and offset adjust voltage. Let's go to the measurement tab. If you have the board configured with the input shorted to the common mode out, we'll expect about common mode voltage on the output. Should be around 1 volt. Press the run button and it will capture data for 1 second. On the x-axis we have time over 1 second, and on the y-axis we have voltage. You can see the mean is just about 1 volt. The peak-to-peak variation, or the peak-to-peak noise, is 1.25 millivolts. And also we have the RMS noise. This concludes the demo of the LMP91050 software. You could reference the user guide to have more information on the entire suite of features. Enjoy the evaluation kit. And signing off, this is Jason Seitz. Take care.